My setup is good to go. I'm ready to measure wheel runout. The difference between measuring wheel runout and brake rotor runout is that wheel runout should be done two ways. In this setup, I'm measuring axial runout. I'm gonna have to measure radial wheel runout as well. I'll show you how that one's done in a sec. What you do for measurement is that little thing is the balancing weight on the wheel. So you cannot possibly do a full circle, just almost a full circle. So you kind of have to start there and just spin the wheel around once and look at the needle what it does. Spin the wheel at a nice and steady pace, and come on in closer and see how the instrument is doing here. You're gonna give me a sec here. There, you can see it well enough that it's pointing almost at the zero. It's a convenient start, but it doesn't have to be. It can point at any number really. Okay, let's spin the wheel at a nice and steady pace, see what it does. So far it's 1/1000th of an inch. Whoop, it's going. That's about 8/1000th of an inch there at that spot. It's got a wobble in it. Oh, it's going the other way now. That's about another 8. No, that's another 6.5. Okay, we'll call it 7/1000th of an inch. Oops, I hit the little weight. Okay, so 8 plus 7 is 15/1000th of an inch. That's close enough. That's good. That's standard casting manufacturing tolerance. Okay, and I changed it a little bit, so see if I can get back to zero. Thereabouts. Okay, let's go around just one more time, starting at the zero. That was about 6. Swinging the other direction, that's about 8. That was 9 in that direction now, and we didn't get back to zero. Okay, just set it to zero there, because this time I didn't hit the weight. Okay, let's go around one more time. That's about 8 there, and that was 6, 7. Alrighty, so it's at 15/1000th of an inch in axial runout. Now the radial runout looks differently. Just come back here a little bit. For the radial runout, you would need to set up this instrument in a way that it's measuring wheel runout in this direction. It's really hard. Maybe you can read it from, you're gonna have to read it from the opposite side of the wheel, but this would be the idea. Okay, so it's measuring wheel straightness in this direction, whereas with the first measurement we measured straightness of the wheel in this direction. 15/1000th of an inch, that's typical casting and manufacturing tolerance, because this is just vacuum cast in one piece. You don't have to repeat it on the other side of the wheel. You can if you want to. You will find that it's going to be different, as it's got these minute little humps and imperfections in it at different spots. So that's how you measure wheel runout or out of round. The setup is, just briefly, the wheel is up in the air, and how I did it is with this unsophisticated 2x4 here and a piece of an I-beam that's been hacked off here with a blowtorch. This I-beam is incompressible and is providing a solid and firm base. The 2x4 isn't so firm and solid, but it shouldn't be. This little portion here that's being cantilevered out is not gonna break because it's short enough, but the 2x4 is soft enough so as not to damage the underside of my fork. this piece of I-beam here is set up on a firm and level base. So is the kickstand and the rear wheel on the motorcycle. The bike is in gear, so it doesn't roll forward, and the steering is locked, so it doesn't move, and it's fairly stable. So whatever you do, fellas, you be safe out there. Be creative though. I have set up on this side of the bike as well, just to double check my measurement and average out the left side and right side and the differences. I want to eliminate the differences so they don't throw off my measurement and I don't start doing something that I shouldn't or is unnecessary. So same setup on this side, radial run out. Yeah, let me just zoom in a little bit so you can have a better idea about this measurement. It's almost sharp, just give me a little time here. There. Let's start there at 10 this time, just for the fancy. Okay, let's go around once, nice and easy. That's about 3/1000 of an inch there, and 4/1000 of an inch there. And let's see what else. That's 2, that's good. And we're basically back to 10, and we're hitting the balancing weight on this side. So 4 on one side of the 10, 3 on the other side, that's 7/1000 of an inch. I think on the other side I measured like 15 in total. On this side it's only 7/1000 of an inch. This wheel is straight. Basically, on the other side I just found a little casting hump or a little bit of irregularity in it. Keep in mind, if your axle is bent, the wheel run out will be greater. And if your axle is straight, the wheel run out will be normal again. So the axle will influence the wheel run out both axially this way or radially the other way. So that's all I have to say about this.